Hello everyone, welcome to Top Scholars, the Smart Learning App. So, in our quest of bringing you important questions which could make their way in your examinations, we are coming up with the next chapter, that is metals and non-metals. In this chapter, you might have already studied about what are the physical properties of metal, what are the chemical properties of metals, and then we proceed with the extraction of metals, right? Also, reactivity series is kind of an important thing that you should not miss. So, let us start with dealing the questions, and with that we will also try to revise most of the concepts that are present in your chapter. The question here is about carbonates and sulfide ores. Okay, the question says carbonates and sulfide ores are usually converted into oxide during the process of extraction. And what is the reason behind this thing? Fine. So, first of all, students, you need to know what are ores. And then we will talk about what is carbonate and sulfide ores, right? Ores basically are the complex forms of metals that we obtain from the earth's crust, right? And then we will do the extraction procedure on that thing to gain the actual metal, right? Now over here we are supposed to answer why the carbonate and sulfide ores are converted into their oxide during the extraction process. If you will remember, friends, when we have the ores, right, first step that we do is the concentration of ores. After this, we have three types of metals that are present in our reactivity series that you might have already studied in your chapter. First group of metals are very reactive. Then we have the metals which are having medium reactivity, and finally we have the least reactive metals. Least reactive metals like your silver and gold are present in the native form itself. But when we talk about the most reactive and medium reactivity series metals, then those are found in combined form, right? And hence we need to convert them into some different forms so that we will be able to gain the exact metal from that ore. Now, if I talk about the metals which are having high reactivity, we will undergo electrolysis on those metals, okay? After doing this step, we will be getting our purified metal. But for those metals which are having medium reactivity, we have two kinds of ores present. That is, first one is carbonate and the next one is the sulfide ores, right? Now, you might be familiar with the terms such as calcination and roasting. Fine. In carbonate ores, remember this C with calcination, okay? That means for carbonate ores, the step undergone is of calcination, and for sulfide ores, the step undergone is roasting. Fine. So, these are the fundamental things that you should be remembering while you are attempting the questions coming from this chapter. Now, coming back to the solution part of this question. First of all, friends, these are usually converted into oxides during the process of extraction because metals can be easily extracted by the reduction of their oxides rather than from their carbonates and sulfides. Say for example, I am having this CaO oxide with me. What you will need to do to remove this oxygen from this compound? Yes, this oxygen needs to be lost, right? So, for removal of this oxygen, the process that we need to do is of reduction. After reduction, we will be able to remove this oxygen and this calcium will be free for us to have the purified metal. Now, over here, we are saying that only because metals can be easily extracted by the reduction of their oxides than from their carbonates and sulfides. Hence, we are trying to convert the ores which are in carbonate and sulfide form to turn them or to change them into oxide form, because then we can be easily converting that form into the metal form. Going ahead, friends, over here you will see some example. The first one is extraction of zinc. We will be having the sulfide ore, that is ZNS, okay, zinc sulfide, that is converted into ZNO by roasting process. Over here you will see we will be having the reaction which says ZNS, that is zinc sulfide, is reacting with oxygen. Remember friends, when we are talking about roasting process, it involves the presence of air. there is the supply of oxygen for this reaction. But when we are talking about calcination process, there we have limited supply of air, or we can also say that oxygen is absent in that process. But over here we are using oxygen. Obviously, we need to have the oxide, then we need to add or introduce our oxygen atom in the picture. So, this zinc sulfide is reacting with oxygen and then we are forming zinc oxide along with the liberation of SO2 gas. Also, friends, try to balance the equations that are coming during your practice sessions. Now, in this chapter, the context is of this ZnS, O2, ZnO and SO2. But keep a habit of balancing the equations so that your other chapter, that is chemical reactions, your acid bases, every chapter's foundation or fundamentals will be thorough and clear. So, we have created the ZnO. Now, after the reduction of this ZnO, we will be able to create the metal, right? Hence, we are saying that the conversion of carbonates and sulfide ores into oxide is easier for the process of extraction. This is the reason. By doing this, you will be gaining your 2 marks for sure if this question comes in your examination. Also, friends, there is a part of the practice session is that whenever you are trying to answer this type of questions, it may not be happening that the question exactly will come in your exam, right? They may ask you a different form but the same concept. So, you should be able to apply this concept in various forms in which the examiner needs you to answer the question. Alright. The question here is, what is anodizing? So, here it is simply asked, what is anodizing? If you remember clearly, anodizing is done using the oxide of aluminium. So, the question may change that why aluminium oxide is used for anodizing purpose. Then also we will be answering with the same content. Hence, you should be able to extrapolate your knowledge to best suit the question that is being asked to you. Alright. So, in here friends, what is actually happening is, we are having the anode. Okay. This anode we are making of aluminium. This is clean pure aluminium. And there is the solution of dilute acid, say for example H2SO4. Now what happens is, this O will be going towards and combining with this Al, thus producing Al2O3, that is the oxide of aluminium. And anodizing is the process of coating your metals with aluminium oxide so that there will be no wear and tear, or the quality of the metal will be preserved for a longer time. Okay, let us go for the solution part. So, here we have the first point denoting you the meaning of anodizing process. It is an electrolytic process. Please remember this word. You need to write electrolytic in your answer if such question comes up. Alright. So, anodizing is an electrolytic process for producing thick oxide coatings, usually on aluminium and its alloys. What do you mean by alloys over here, friends? Yes, alloys are mixture of different metals, and those mixture will be having different properties from the constituent elements. Okay, so if I say my iron is rusting a lot, I will mix some other metals and then I will have an alloy which is now resistant to the corrosion. Okay, so that is the meaning of alloys. Here, anodizing is an electrolytic process for producing thick oxide coatings, usually on aluminium and its alloys. Going ahead, this is used to give improved surface resistance to wear and corrosion, or as a decorative layer. Now, this Al2O3 that we are getting, Al2O3, this can also be dyed. Okay, we can have the introduction of dyes to this thing, and then we will have a decorative layer on our metal. So, that is the uses. First of all, we will have the surface resistance. It will not wear, it will not corrode that much easily. And then there is an extra benefit that it can be also used as a decorative layer. Going ahead, in the electrolytic process, what is done? The components to be treated are made as anode, just as we have discussed. Okay, so the components to be treated are made as anode in a dilute acid solution, and then we will be having the creation of Al2O3. Now, why I am saying Al2O3 over here? Because aluminium is mostly used for anodizing purpose. Alright. The question here is, the question says, when most of the metals are treated with nitric acid. Okay, what is nitric acid? It is HNO3. You should be remembering the chemical name, chemical formula for these things as well. They do not produce hydrogen gas. Why? So over here, we are reacting metals with nitric acid. Okay. We are supposed to have hydrogen gas liberation, but that is not happening in this case. And now we are supposed to give reason so as to why is not hydrogen gas evolved. Alright. So over here friends, first of all, we need to have the nature of this nitric acid that is given to us. This is a very strong oxidizing agent. That means it will oxidize the other component, but itself it will undergo reduction. Now it will oxidize, meaning it will be adding oxygen, right? Now, say for example, this hydrogen gas is being liberated, but this one is a strong oxidizing agent. So what will it do is that it will go and oxidize this hydrogen gas, and therefore this H2 will be converted into H2O. So basically an oxidized product of H2 is produced, that is water, and hence we are not able to see the production of hydrogen gas in this reaction. Now let us continue with the solution part. Nitric acid is a strong oxidizing agent. When a metal reacts with nitric acid, it oxidizes the hydrogen to produce water. Okay. Over here, as you have seen, you need to remember the general reactions that are coming in your chapter. That is, when metals are reacted with acid, what is the product? That is very much clear to you at this stage because you have been revising and reading the stuff for a lot of time. You need to just apply that knowledge in the questions and try to attempt them. Alright. So, this hydrogen gas is produced, but it is undergoing oxidation to form water, and hence we are not able to see the hydrogen gas. So herein the questions are coming from reactions. In this chapter, you are dealing with metals and how they react with other things, like how their oxides will behave. Are all metal oxides dissolving in water? If not, which are the metal oxides that don't dissolve in water? Alright, then you have different reactions coming up in this chapter from which questions will be framed, and you must therefore understand reactions thoroughly before you attempt the questions which are coming from this chapter. The question here is, explain any 3 methods used for preventing corrosion of metals. Okay. Now again we have the question coming up, what is corrosion of metals? This question we have dealt in other sessions as well, and it is very common as well, right? When the metal's quality is being reduced due to formation of other things, other compounds, then we say the metal has been corroded. Like say for example, iron sheet is there or iron gates are there, but in rainy season, because of the moisture or the gases that are present, we have a different structure that is being formed on that iron. Okay, basically that iron is being converted into iron oxide. So now we will say that iron has been corroded. Alright, same goes for copper utensils as well. Those will also be forming some corrosive materials, and that's why we are having different coloration, different properties of that metal. So for tarnished copper vessels, it is recommended to rub it with tamarind juice or lemon juice. Basically, the acid that is being released will be able to cope up with the corrosion material that is being produced on that metal. Okay. So coming back to our question, explain any 3 methods used for preventing corrosion of metals. You might have seen that these iron gates that are present outside of your buildings or houses are regularly being painted. Okay, why are they painted? Yes, to prevent the corrosion. So there are different mechanisms in which we try to prevent the corrosion of metals. Say for example, oiling, greasing, painting. Then we have other things as well, that is galvanizing. So all of these things you can mention in this question and you will be able to grab your 3 marks very easily. So again I am telling you to relate or correlate the concepts in your study to the common things, daily things that are happening in your life. Alright. Going ahead for the solution part, the very first thing we are going to learn is about galvanization. Galvanized metal is coated with a thin layer of zinc. Please remember this word, that is zinc, with the chemical formula of Zn. Okay, this is a metal. So, galvanized metal is coated with a thin layer of zinc to prevent it against corrosion. The zinc oxidizes when it is exposed to air, creating a protective coating on the metal surface. So, after oxidization, zinc oxide is formed, and this is formed due to exposure to the air. and thus a protective coating is present or created on the metal surface. In this way, we can prevent the corrosion of metals. Going ahead friends, the next thing is alloying. This we have already discussed in our session just now. We just have to go through it once again. It says that it is the method of improving the properties of metal. As we have just said, it increases the quality of the metal. So, we are improving the properties of metal by mixing. Okay, please remember these words, by mixing the metal with another metal or non-metal. So, there is no compulsion that metal should be mixed with metal only. We can have non-metal as well. But we are doing all of these things to increase or to improve the quality of the existing metal. So, over here we are provided with an example when iron is alloyed with chromium and nickel. That means we have iron, then we have chromium which is having the chemical symbol of Cr, and then we are having nickel. Please remember these combinations because this will create your stainless steel, okay, that you might have been using in your homes already. So, iron is very much prone to corrosion, but its alloy, that is stainless steel made up of iron, chromium and nickel, is resistant to the rusting process itself. So, you see we have just improved the quality of our metal by doing this alloying procedure. Going ahead, we have to discuss 3 methods for corrosion prevention. The third one is greasing or oiling, as we have just said. When we have some grease or oil that is being applied to the surface of metal, what will happen is the contact between the outside environment and that metal is being blocked, right? If I am having this metal and this is the protective layer of oil or grease that I am adding, then this metal is now not exposed to the outside environment, and thus the outside gases, moisture are not getting to it, so the corrosion process is prevented. Okay, as simple as that. So, when this is applied to the surface of an iron object, then air and moisture cannot come in contact with it and hence rusting is prevented. So, in this chapter towards the end, we have the details about corrosion things, right? And these are very simple and you can relate it with your daily activities. Hence, you need not and you should not miss the components of the details that are present in this topic of corrosion. The question here is, it says, what are amphoteric oxides? Now, there is a tip friends, always remember that amphoteric oxides always come with zinc and aluminium name. That means zinc and aluminium always give you the production of amphoteric oxides. Then after doing this mental check, you will proceed and go with the question, what is it asking? Okay, so now we have done that, we will proceed with our question. It says, choose the amphoteric oxides from amongst the following oxide. So that means we need to just choose or spot what are the amphoteric oxides. Now, we have to just identify if the question is asked for 1 mark, but over here it is asked for 3 marks. So, you need to explain the details why the chosen options or alternatives are amphoteric in their nature. Alright, depending upon the marks, you will change what you are giving as an answer. Alright friends. Now over here we are provided with some examples of oxides and we need to identify and justify which one of them are amphoteric oxides. So going ahead for the solution part, amphoteric oxides, what are these is the first step that you need to understand to attempt such question in your examination. Amphoteric oxides are the type of oxides that reacts with both acid and base. That means metal oxides, when they are generated, they will either be acidic or they will be basic. But amphoteric oxides are those which will have both the properties. That means they will have acidic behavior as well as they will be having the basic behavior. And that's why they can react with acids as well and bases as well. Okay. So, this is the meaning of amphoteric oxides. As referring to our mental check, we can say that this ZnO and Al2O3 are for sure amphoteric oxides. Okay. But going ahead and dealing with each and every entries that are given to you is a good way to approach a question and cover all the related topics that can be coming in your upcoming examination. Alright. So over here, amphoteric oxides possess both properties of acid and base as just we have said. Going ahead, let's deal with this Na2O. So this is the oxide of sodium. As you can see, sodium is present, oxygen is present. We will say it as sodium oxide. This one is containing oxide ions. That means it is having O2 minus. Okay, this is the oxide ion. This sodium oxide is containing oxide ions which is acting as a strong base. Alright, and therefore it easily combines with hydrogen. So the thing to notice over here is this compound of sodium oxide is having oxide ions, and then this oxide ion is a strong base. So what do you think, friends? This sodium oxide will have acidic behavior or basic behavior? You can have a general thought. We have provided you with enough information to make an educated guess. We will proceed to our further answer. This sodium oxide is basic in nature, okay, because the oxide ions present are strong base and therefore it is combining easily with hydrogen. Alright, so we can rule out this option from the question. This one is not an amphoteric oxide because it is just basic in nature. It is not acidic as well in nature. Alright, now we will go ahead and deal with these two. Coming up over here is the detail about ZnO, that is zinc oxide. Going ahead, let us see how this zinc oxide reacts with acid. Alright, so ZnO plus H2SO4, which is an acid, right? There is no doubt in your mind that H2SO4 is an acid or base. Now, why it is an acid? Yes, because it will be producing H plus ions, okay, which will be shifting your pH value to lesser than 7 on pH scale, and hence we are saying that this one is an acid. Going ahead, friends, this zinc oxide is reacting with H2SO4 and then zinc sulfate is formed along with water molecule. So over here we can go ahead and extrapolate this reaction to understand or correlate with another concept that we have learned in another chapter. That is over here. This SO4 part is going and attaching to the Zn, right? And then this O is going for H2. Hence we are getting the formation of H2O. So there is displacement occurring and there is double displacement. Displacement is going on 2 times. Hence we will say that this reaction is of double displacement type. Okay. So we have covered your chemical reaction in equations chapter as well by this reaction. Also, try to always check your reactions are balanced or not, because there might be a situation in which an unbalanced equation will lead to the deduction of your marks. Alright, friends. So going ahead, we have the production of zinc sulfate, which is a salt, right? Zinc sulfate is a salt. And then we are having the production of water. Now friends, let us see how this zinc oxide is reacting or behaving with a base. So for base, we will be using NaOH, which is a strong base, right? There is no reason for us to justify why this one is a base and why it isn't an acid. Alright. So going ahead, this zinc oxide is reacting with NaOH and then we have the formation of sodium zincate, that is a salt, and along with it water is also formed. So friends, as we have just saw that this ZnO is reacting with acid as well and it is giving us the products, and it is reacting with base as well to give us the products. That means that this ZnO is showing both acidic as well as basic behavior. Hence we will say that this ZnO is behaving as amphoteric in nature. Okay, ZnO, that is zinc oxide, is amphoteric in nature. Now let's go ahead and deal with the next thing, that is Al2O3. This is aluminium oxide and we will see how it behaves with an acid. Al2O3, when it is reacted with HCl, HCl is hydrochloric acid, right? Now what we are forming is aluminium chloride, which is a salt, and then we also have the production of water. So over here you will see that this Cl is going and displacing the oxygen, and then we are having the formation of AlCl3, and then rest of the thing is going as water. You may check again, this is also a balanced equation. So the context over here is this aluminium oxide is reacting with the acid and it is forming aluminium chloride along with water. Now let us see what is the behavior of aluminium oxide with a base. Okay, for base we are taking over here is NaOH again. So this is sodium hydroxide, no need to mention it again. So Al2O3 is reacted with a strong base, that is NaOH, and then we are forming again a salt, which is sodium aluminate. Please remember the chemical formula for this, okay? It is NaAlO2 and along with it we have the water formation. Now again, the context over here is that this oxide is reacting with acid as well as it is reacting with the base. Hence, we will say that this one is also an amphoteric oxide. Okay. So, thus concluding that this aluminium oxide behaves as amphoteric in nature. Okay. So, we have just concluded that ZnO and Al2O3 both are amphoteric in nature. Now, we are left with other two entries. Let us deal with that. First of all is carbon dioxide. Now, this oxide is itself not acidic, okay, it is a neutral molecule. But when you will dissolve this CO2 in water, what will be forming is carbonic acid, alright. This carbonic acid is having acidic character. So, we will extrapolate this knowledge and we will say that CO2 is acidic in nature, okay. Carbon dioxide is acidic in nature. There is a general rule, friends, that metal oxides are generally basic in nature and non-metal oxides are generally acidic in nature. You can use that knowledge as well to attempt this thing, because C, that is carbon, is a non-metal, so its oxide will be acidic. Okay, just a hint or correlation of the topic at hand with the metal and non-metal part, right? Going ahead, let's go for the last one, that is H2O. Now, this H2O is having the pH of 7, that is already known to you, that is very common knowledge. It is having the pH of 7. So, what is happening is, when you will see the concentration of OH minus ions and the concentration of H plus ions, you will see that they are equal. Okay. Hence, we will say that there is no disturbance in the equilibrium state of this water molecule. Going ahead, therefore, we will say that water is also behaving as amphoteric in nature, because acidic ions and basic ions both are in equal concentration. Okay. So, you got how we are considering water as well as amphoteric nature. Okay. Going ahead with the correct answer, we can conclude that these oxides, that is zinc oxide, aluminium oxide and water, all are having amphoteric nature. The rest of the things were not amphoteric oxides. Alright. The rest of the entries, that is sodium oxide, is basic in nature. And then one last one was that of carbon dioxide, which is acidic in nature. Here is the question. It says, why is that non-metal do not displace hydrogen from dilute acids? Now friends, for anything to displace hydrogen from acids, it needs to be more reactive than hydrogen. That is the first fundamental criteria for any displacement to occur. The displacing atom should be more reactive than the partner atom of hydrogen or other things. Alright, we are being asked why is that non-metal is not displacing hydrogen from dilute acids. So now can you guess what will be the answer for this question? You may pause the video and ponder upon your answer. We will be proceeding with the solution part. So over here, non-metals do not displace hydrogen from dilute acids because unlike metals, okay, non-metals are obviously different from metals. So they will be having different properties than those of metals. These non-metals do not have a tendency to lose electrons, but they have a tendency to gain electrons. Okay. Now, if I talk about an example over here, say for example, I have sodium at hand. Okay. The electronic configuration is 281. Now, all the periodic table knowledge in this concept is clear to you. This one is in K shell, this one is in L shell and this one is in M shell. If I say this is the first orbit, second orbit and third orbit. So, what is the tendency of this sodium while it is undergoing a reaction? It will always tend to lose this one, right, electron. Why is that so? So that it will be able to accommodate the noble gas configuration, that is of 2,8, so that it will become stable. All the reactions that is being undergoing in your system or in your chemistry is all because they tend to have the stability. Okay. Hence, this sodium will tend to lose this electron, and say for example, I have another atom at hand which is chlorine. Its electronic configuration is 287. Okay. So now, what is the tendency of this chlorine atom? It will be having a preference to gain one electron. Okay. Then what will happen? It will be having a noble gas configuration of 288, thus becoming stable. Alright, that is only being said in the first point, that metals have a tendency to lose the electrons while non-metals have a tendency to gain the electrons. Going ahead with the next point, it says that metals have a tendency to lose electrons, as we have just saw. Then these electrons which are readily lost by the reactive metals like sodium, potassium, etc., these are being accepted by the hydrogen ions of the acids. Acid, because we are talking about acid in this question. So, the hydrogen ions that are being lost will be taken up by the dilute acids, and then they will be reduced to form the hydrogen gas. Alright. So, for occurrence of all of those things, it is important that the species should be more reactive than the hydrogen atom. But over here, non-metals are not reactive. The sentence says only those metals which are more reactive than hydrogen will displace hydrogen from acids. Alright. Thus, this is the reason why non-metals do not displace hydrogen from dilute acids. Here is the question. The question says, what is thermite reaction? Give its one use. This thermite reaction is being asked in your previous year question. So, as a default strategy, you must understand what is thermite reaction. In your textbook, there is a spelling error for this thing. This E is not being added. So, it is thermite reaction. But please remember, this one is called as thermite reaction, and what is the spelling for it as well. Going ahead, what is thermite reaction is the question, and we need to give one use. Please friends, try to bifurcate the marks that is being provided to you to the question that is being given to you. Over here, the first question is what is thermite reaction? So, it might be having 1 mark, and then you need to give one use, that will be carrying 1 mark again. Okay. So, over here, let's proceed with the thermite reaction. Thermite reaction is basically iron oxide, that is rust, that we have talked in this session as well, right? That iron oxide is reacting with aluminium to produce molten iron. So, thermite, this I, you can correlate it with the iron production. That iron is in molten state. And how you are producing it? You are producing it with iron oxide, that is Fe2O3. That oxide is reacting with aluminium, and then you are having the production of molten iron. So, over here we have also mentioned the products, that is aluminium oxide, elemental iron, and a large amount of heat. Since there is large amount of heat liberated, there is the name of thermite reaction. Okay. Let us have a look on the reaction as well. This is Fe2O3, that is iron oxide that we have just mentioned, and aluminium is reacting to this iron oxide. Now, Al2O3, that is aluminium oxide is formed. This Fe is going on to form the elemental iron, and then there is heat production. Okay. So, thermite mixture is this aluminium powder along with the rust, that is iron oxide. So, for this reaction friends, you must remember what is the reactant and what are the products that are being formed. Also remember that molten iron is produced, and along with that a very much high amount of heat is being liberated, and hence we have the name as thermite reaction. Going ahead friends, when this mixture is heated, that is of aluminium powder and your iron oxide, when that is heated, it starts reacting as aluminium is more reactive than iron, and aluminium thus forms stronger and more stable bonds with oxygen than iron. Now, if you remember the reactivity series, what is happening over there is we have K, then we have Na, then we have Ca, then you are having Mg, Al, we are having Zn, and then we are having Fe. Okay. So, you will see that this reactivity series, over the top you have the most reactive metals, okay, most reactive, and towards the bottom as you will go downward the reactivity is decreasing. So, this Fe is less reactive than Zn. That means this Zn is more reactive than Fe. So, we are saying that when we are reacting this Fe2O3 with aluminium, these were the reactants in your thermite reaction. What will happen is, aluminium being more reactive than iron, this will go and displace iron, okay, and thus forming aluminium oxide and elemental iron. Alright. So, coming back to our solution part, the next thing is, what are the uses that are being asked to you? The reaction is used for thermite welding, often used to join the rail tracks. So, whenever there is breaking or there is cracks in rail tracks, then this reaction is used for joining those railway tracks. Going ahead, one more use is that thermites have extremely high temperatures and have also been used in metal refining, demolition of ammunition. Ammunition is present and demolition is required. So, this thermite reactions are being used. And then incendiary weapons demolition is also being done using this reaction only. So, this was all about the thermite reaction and what are the reactants and products for the same. Or along with it, we also had the uses for this reaction. The question here is, it says in the electrolytic refining of a metal M, what would you take as the anode and cathode and the electrolyte? So basically, you are just being asked about the electrolytic apparatus. Okay? If I say this is the beaker in which your electrolysis is going on, then here is the anode, here is the cathode. The question is asking you what will be the anode, what will be the cathode, and what will be the electrolytic solution that is present over here. Now over here, let's say this one is the anode, okay, and this one is the cathode. So over here friends, we will be having anode which will be the impure form of the metal, okay. That means M along with the impurity. So the impure metal is being used as the anode. The cathode is the pure metal, okay, and this electrolytic solution will be the salt solution of that metal itself, alright. That is being asked and you need to mention all of these things and you will be able to gain your 1 marks very easily. Also, do not forget that electrolytic apparatus should be connected with the battery so that the electrolysis will start to occur. Alright, going for the solution part, what we have just discussed, we will write it in sentences. So, a rod of impure metal, that is M, would be used as an anode. Please remember, impure metal as anode. And then a thin strip of pure metal M would be used as the cathode. Cathode is the electrode with the negative side and anode is an electrode with the positive side when we are talking about electrolysis as such. Then a water-soluble salt of M would be used as an electrolyte. Why we need to have a water-soluble salt? Because you will be dissolving that salt in water, right? Then only you will be having the production of electrolyte itself. Then going ahead, when current will be passed through the electrolyte, when the batteries will be connected and the current is passed, then the impure metal from the anode is dissolved in the electrolyte and then the same amount that is being dissolved will go and get deposited on the cathode. So, in this way, we can have the electrolysis process to gain our metal of interest. Okay. For the question sake, you will be answering this much and you will be getting the marks because you have mentioned what is present as anode, what is present as cathode and what is the electrolyte that you are being using. Okay. This is for your understanding process. That we are at hand with the electrolyte and the electrolyte solution, you should also know what will happen after the electrolysis has occurred. Alright. Here is the question. The question says, write the steps involved in the extraction of pure metals in the middle of the activity series from their carbonate ores. So, as we have just mentioned the reactivity series, then finally we are having Mg, Al, Zn, Fe, all of those things. So, in that series, which of the metals are having medium reactivity, that you need to remember in such questions. So, going ahead, we need to write the steps which are being used to extract the pure metals in the middle of the activity series from their carbonate ores. Now, over here friends, you are also provided with the hint of it being carbonate ores. We have just talked in the start of our session that, so this question is coming from the topic of the extraction of metals in your chapter. Let us proceed with the solution part. Over here, we will be having the extraction of pure metals from carbonate ores. First step will be concentration of ore. We have just answered this question at the beginning of our session with the first question itself. We are just going to have a detailed and written answer for you over here for gaining that 3 marks that is being provided. So, the very first step is concentration of ore. In that, we will be removing the impurities. Okay, the impurities that are present along with the ore is called as gangue. So, you have learned that this gangue is removed from the ore in the concentration of ore. Now, remember friends that this question might be coming as a fill-up or an MCQ and you should be able to answer that this gangue is the impurity that is present in the ore. Okay, going ahead with this question, then we have the step of calcination. Remember, we have just talked that in this calcination step, there is limited supply of air or there is absence of air. Okay, so let us proceed with that idea in our mind. The carbonate ores are changed into oxides by heating strongly in a limited supply or absence of air. In the question, I just told you that carbonate is given, so you can take some hint over here. This carbonate C will be linked to the term of calcination. Okay. Hence, we will say the next step is of calcination and we are going for carbonate ores as well. So, what we will be doing is carbonate ores are changed into their oxides. Why we are changing them into oxides? That also we have discussed in our session earlier, right? Because these oxide, when we are getting of the metal, then it is easier to obtain metal from them following the process of reduction. Okay. So, these carbonate ores are being changed into oxides by heating strongly in a limited supply or absence of air. Then we will be having the metal oxide. Here is an example given to you. We are roasting ZnCO3, that is the carbonate of zinc. Then we are having the formation of ZnO along with carbon dioxide. Now, this will be reduced and then we will be having the metal in our hand, right? The next step is of reduction by carbon or more reactive metal. The metal oxides are then reduced to the corresponding metals by using suitable reagents such as carbon. So, after introduction of carbon in this ZnO, you will be having the formation of Zn. So, friends, as we have just said that this ZnO needs to be reduced and in this step, we are being reducing it with carbon. If you remember in your textbook also, it is being said that the metals which are having medium reactivity are always having the last step of reduction by carbon. Okay, carbon is a metal or non-metal? You should be remembering that it is a non-metal. So, it will be having a reduction by carbon and then we will be getting this Zn as our free metal. So, this question is again coming from the extraction of metals topic from your chapter. So, you should be having a quite grasp on this topic of the chapter. The question here is asked for 1 mark. The question says, why silver metal gets tarnished when left exposed for some times? Now, you have learned the chapter, you are also listening to this session attentively, I guess. So, you will be easily able to answer this question. So, over here, the one word answer for this question is corrosion. The silver metal is corroding and that's why there is a tarnished appearance to that metal. Let us explain them to gain that 1 mark that is present for this question. The solution part says that silver reacts with sulfur compounds that are being present in the air. Alright, what sulfur compounds? Like H2S, hydrogen sulfide. So, this silver is reacting with sulfur compounds present in the air and that is leading to the formation of a black colored compound which is called as silver sulfide, and that was the tarnishing material that we were seeing after we have left the silver metal exposed to the surrounding environment. Alright, so this is the answer that will give you 1 mark. You knew corrosion was going on, but you need to tell what is the compound that is being formed to gain your marks properly. Alright. The question is of MCQ type and it is asked for 1 mark and it is assertion and reason type of question. These questions are easy to grasp if you have a understanding of the knowledge at hand. Okay, let us go for the assertion statement. It is saying that the color of copper sulfate solution, that is CuSO4. You might be remembering what is the color of this copper sulfate solution? Yes, you have copper, so you need to link it with the blue color. Okay, so the solution is bluish in color. The color of copper sulfate solution changes when a piece of zinc is dropped in it. Alright, so we have a beaker or a flask in which there is copper sulfate solution and then we are dropping zinc pieces, solid zinc pieces in that, and now we are saying that the color is changing. So, we have taken a flask in which copper sulfate solution is there and now we are adding pieces of zinc and the condition is that the color of the copper sulfate solution is now changing. Okay, this is the assertion statement given to you. You need to check whether your assertion is true or not, because after that you will be able to eliminate at least one option. If the assertion is true, you will be eliminating this option. If it is false, then you will be eliminating all of these 3 and you will get your correct answer. Okay. Now, going for the reason statement, it states copper is more reactive than zinc. Okay. So keeping in mind the reactivity series of metal, you can simply answer this question. Okay. Now, the options are given to you. Both A option says that both A and R are true and R is the correct explanation of A. B option says that both are true but R is not correctly justifying the assertion statement. Option C says that A is true but R is false, and option D states that A is false but R is true. Now, I will be writing the reactivity series over here and you make a guess whether this reason statement is true or false. So this is the reactivity series. I have written only those elements that are being concerned with this question. The reactivity goes like this, the highest over here and the least are towards the bottom. Now friends, what we are being told is CuSO4 was present, okay, and then we have added zinc to it. Now, as per our understanding, zinc is more reactive than copper, okay, because it is present on the topper side and this is present at the bottom side. So, this zinc will displace Cu, okay. What will be the compound that is formed? Yes, it will be zinc sulfate, okay. And this copper will be going out of this CuSO4 compound. That's why the blue color that was present earlier is now not visible because the compound is not there to give you the blue color. Alright. So, this Zn is more reactive than copper. In reason statement, it is written that copper is more reactive than zinc. So, if you remember the reactivity series, some elements and in their correct sequence, then you can easily attempt this question and many more questions if to be honest. Okay. So, we can say that this reason statement is incorrect only. Assertion is true but reason is false. Okay. These two options were saying that R is correct but it is the correct explanation or not correct explanation of A. And the last option says that R is true. So, just coming to the conclusion that R is false, we can choose this option as our correct answer. Okay. And A is true because as per explanation. Because as per our explanation as well, we saw that CuSO4 was blue, but then this compound is being decomposed and hence the blue color is vanishing. So, assertion statement also holds true for this question. Going ahead with the solution part, let us see over here. The color of copper sulfate solution is blue. When a piece of zinc is dipped in this solution of copper sulfate, it forms zinc sulfate as we have just seen, and the copper metal is displaced because zinc is more reactive than copper. Over here, we will say that zinc sulfate is colorless solution and hence there was disappearance of blue color. That's why the solution becomes colorless. This displacement takes place because zinc is more reactive than copper. This is the ultimate statement on which you can easily attempt this question. Alright. The question here is, why do copper objects develop a green coating on them? Again, the answer simply is corrosion, but we will be explaining it to gain our 1 mark. So, let's begin with the solution part. It says that when a copper vessel is exposed to moist air for a long time, it develops a green layer on its surface. What is happening is this copper utensil or the copper metal is getting corroded, that we know for sure. Copper is corroding by oxidation in which it reacts with oxygen in the air to form carbon oxide. But we need to go and find out what is this green compound that is being formed. Okay. Now, this copper oxide is then combining with carbon dioxide in the atmosphere to make copper carbonate. Now, this is having green color. Okay. And this process is now referred to as corrosion of copper. So, first of all, copper reacted and formed copper oxide, and then that oxide also reacted with carbon dioxide to form copper carbonate that is having the green color. Now, over here green coating was mentioned, hence we need to go and answer which compound is actually having the green color. Okay, and hence you need to write this much for obtaining the green colored compound. This process is called as corrosion of copper. Let us have the chemical equation for this reaction. Here, the copper is being reacted with water, CO2, O2. We are writing it as it is, okay. Hence, we are forming the copper hydroxide along with copper carbonate. This copper carbonate is nothing but that green material that was observed on the copper object or copper utensils. And that is leading to the corrosion of the copper metal. Over here, again, we have mentioned that copper carbonate, that is CO3, is a blue-green compound. Alright. Here is the question. The question says, how are ores different than minerals? A very basic question. We always say that ores are the things that we obtain from our Earth's crust, and then from that we are producing or we are extracting the metals. But minerals are also having the metals. So how can we distinguish between ores and minerals? There is a sentence which says that all ores are minerals, but not all minerals are ores. Okay, you need to remember this. After the solution part, we will come back to this statement as well. So, in the solution part, it says that the elements or compounds that occur naturally in the Earth's crust are known as minerals. Okay, so basically whatever elements or compounds we are getting in our Earth's crust, all are referred to as collectively minerals. Alright, going ahead, now what are ores? Few minerals, okay, all the minerals that we have obtained from the Earth's crust, few minerals are there in which there is good percentage of metals, okay, and we can extract the metal from those minerals profitably, alright. Completing our sentence, it says that few minerals have good percentage of metals. Minerals from which the metal can be easily and profitably extracted are called as ores. Okay, so with these words of easy and profits, you have came to the definition of ores and you have distinguished it with the minerals, because minerals was the name referred to for all the compounds or elements that were present in the Earth's crust. But among all of those things, some were there from which we can extract the metal easily and with our profits as well. So, those minerals only will be referred to as ores. Okay. Hence, we can say that all ores are minerals, but not all minerals are ores. So, that is the distinguishing characteristics in your ores and minerals. Here is the question. It says, how are metals high in reactivity series obtained from their ores? So, now we are talking about K, Na, Ca, Mg, okay, that is potassium, sodium, we are talking about calcium, magnesium. How are we going to obtain those metals from their ores? Please understand this, friends, that all these metals, the highly reactive metals, are never found in free form. They are always found in combined form. Now, what will be they combined to? They are mostly found in oxide form. Why is it so? Because in our Earth's crust, oxygen is abundant and it is also highly reactive. So, these metals are reacting with oxygen and they are found as oxides. Alright. So, coming back to the question, how are metals high in reactivity series obtained from their ores? Explain the process by taking an example. We have in this session earlier discussed that the metals coming in high reactivity series are extracted by electrolysis process. So, we will try to fit that understanding in this question, and this question is asked for 2 marks. Going ahead for the solution part, the metals at the top of the reactivity series can be extracted from their ores by electrolytic process known as electrolytic reduction. Okay? Please remember this electrolytic reduction word. Going ahead, these metals such as sodium, magnesium, calcium, aluminium are very reactive and cannot be obtained from their compounds by heating with carbon. Okay, why so? Because they are having more affinity towards oxygen. Okay, so they will not react with carbon, they will already react with oxygen. Let us complete the sentence. These metals cannot be obtained from their compounds by heating with carbon. This is because these metals will have more affinity for oxygen than for carbon. Going ahead, you are supposed to explain this process using an example. So, we will be taking the example of sodium metal. You know, this is the salt NaCl, this is in molten state. Now, what will happen is we are doing the electrolysis and there is formation of Na plus and Cl minus. Na plus is present at cathode and Cl minus is present at anode. Then, let us see what is the reaction at cathode as well as the reaction at anode. At cathode, this Na plus is accepting an electron and thus it is becoming sodium metal which is being deposited. Okay, so this Na plus is combining with the electron and thus we are forming the Na. Going ahead, at anode, what is happening? There is 2Cl minus and this is losing 2 electrons to become Cl2. Alright. So, in this form, you have seen that we have undergone the electrolysis and what are the reactions for cathode and anode as well. So, if I say that this NaCl was the compound in which Na was found, Then following electrolytic reduction, I have obtained Na separately. Okay. Here is the question. It says, how can we find whether a given element is a non-metal if we know its electronic configuration in a chemical reaction? So just go back and try to recollect that we have written the electronic configuration for Na and Cl. Na was metal and Cl was the non-metal. Na was having the electronic configuration of 281, right? And it was having the tendency to lose the one electron to obtain the stable electronic configuration. Just contrasting was the chlorine atom. It was having the electronic configuration of 287, and hence to acquire a stable configuration, it was easier to accept one electron than to donate 7 electrons, right? You can extrapolate that example and you can easily answer this question. This question is coming for 2 marks. The solution part over here is elements that have 1, 2 or 3 valence electrons are metals as they lose electrons in a chemical reaction. Sodium was having 1 electron in its valence shell, right? So, if it can lose that, then it was acquiring a stable configuration. So, this is the general rule that 1, 2 or 3 valence electrons, if there is presence, then those elements are referred to as metals as they can lose those electrons in a chemical reaction. Just opposite for non-metals, elements that have 4 or more valence electrons are non-metals, alright, as they tend to gain electrons in a chemical reaction. Taking the example of chlorine, you can easily understand this as well. Because it was having more than 4 valence electrons, obviously it was having 7. So, if there is presence of more than 4 valence electrons, then the elements are generally supposed to be non-metals and they will be gaining electrons to obtain a stable electronic configuration. So, with respect to the electronic configuration, we can guess if an element is metal or non-metal. That is the question that is being asked, and hence we have easily answered that question and obtained the 2 marks that were provided to us. So friends, in our earlier videos, you might have understood that there are many questions which are coming from this topic. This session gave you an important question and an idea of how you should be practicing questions along with the revision of the topics that you are doing for your different chapters. I hope the session was useful for you and you have gained knowledge that you may apply for your upcoming examination. Thank you all for your attention.